तो लास्ट क्लास में हमने डिस्कस किया था सेल्फ ट्रेनिंग एंड को ट्रेनिंग के बारे में, राइट। सो सेल्फ ट्रेनिंग में हमने बिगेस्ट प्रॉब्लम ये देखा कि मॉडल में कॉन्फिडेंटली मेक रॉन्ग प्रेडिक्शन एंड इट गोस ऑन एंड takes the form of error propagation or confirmation bias, राइट। को ट्रेनिंग में दो मॉडल यूज किया जाता है, दो सेपरेट मॉडल यूज किया जाता है। सो ऐसा कुछ प्रॉब्लम नहीं आता है मैंने। ओके, नेक्स्ट, how does the level propagation work in graph based semi supervised uh, learning algorithm? How does level propagation work in a graph based semi supervised learning algorithm? So level propagation is a graph based semi supervised learning method. It uses both leveled and unlabeled data by representing them as a graph. In this graph, each data point is represented as a node and similar data points are connected by edges. Okay, तो हर एक डेटा पॉइंट को एक नोड से रिप्रेजेंट किया जाता है जो सिमिलर डेटा पॉइंट्स होगा, एजेस के थ्रू कनेक्टेड रहता है। Now, the stronger the similarity between the two data points, the stronger the connection between them. जितना ज़्यादा similarity रहेगा उतना ही ज़्यादा strong connection रहेगा. Main idea is that similar data points are likely to belong to the same class. Similar data points एक same class में belong करते हैं. First, we create a graph. Right. Step one is the create a graph. Each data point becomes a node in the graph. The connection between two nodes is assigned a weight based on how similar they are. Okay, दो का एक का क्या बोलते हैं, एक कनेक्शन जो है weight असाइन किया जाता है कितना सिमिलर है उसके ऊपर बेस करके। मैथमेटिकल रिप्रेजेंटेशन ये है कि डब्ल्यू आई जे इज इक्वल टू सिमिलरिटी बिटवीन टू नोड्स से आई एंड जे। wij weights of the edge connecting the nodes I and j. Larger wij means the two nodes are more similar and smaller wij means the nodes are less similar, right? Then start with the level node. पहले हमने start किया था graph को create करके. Second, start with level nodes. Some nodes already have non-level. This level nodes acts as a starting points for spreading level information, and the unlevel nodes initially have unknown levels. Okay, say node A get leveled, node B unleveled, node C unleveled, node D doc leveled. तो हमने क्या किया, लेवल नोड के साथ स्टार्ट किया। ये जो लेवल नोड्स हैं, दिस एक्ट्स एज ए स्टार्टिंग पॉइंट्स फॉर स्प्रेडिंग द इंफॉर्मेशन. Unlevel nodes initially have unknown levels. Now spread the levels. Just a minute. Let me keep it in the silent mode. Okay. So during each iteration, every node shares its level information with the neighboring nodes. Neighbors with stronger connection receives more influence than those with weaker connection. The level probabilities are updated using the equation pt plus 1 is equal to t into pt. What does it mean? Here pt is the level probabilities at the current iteration. Pt plus 1 is the updated level probabilities after one iteration. T is the normalized transition matrix that controls how levels move between connected nodes. Okay, so during this iteration, every node shares its level information with the neighboring nodes. Then for keep the original level fixed. After each iteration, the level nodes are reset to their original correct levels. This ensures that the known levels never change while the unlevel nodes continue updating their probabilities. Then repeat until convergence. The level Propagation process continues until the level probability stops changing significantly. At this point, the algorithm is said to have converged and the unleveled nodes receive their final predicted levels. तो ये continue रहेगा until the level probability stops changing significantly. Suppose we have 5 data points, cat and dog. The left circle is level cat, this one, and the left triangle is the dog. Remaining are unleveled. As the algorithm runs, the levels spread throughout the graph. Eventually, nodes closer to the cat cluster receive the cat level, while nodes closer to the dog cluster receive the dog level. तो cat के पास जो रहेगा वो cat leveling हो जाएगा और dog के पास dog leveling. Why is level propagation useful? क्यों level propagation useful है? The level propagation is useful because use both leveled and unleveled data. Take the advantage of the similarity between data points. Predict levels even when only a few level examples are there. Improve classification accuracy with minimal available data. So we can say that level propagation represents the dataset as a graph where each point is a node and each connection has a similarity with Wij, and Wij represents a weight between this I and j. The node levels are graphically or gradually spread to the neighboring unlevel nodes according to the updated formula Ptf plus 1 is equal to Pt into Pt. The level nodes remain fixed throughout the process while unlevel nodes update their level probabilities repeatedly until the algorithm converges. This allows the model to assign levels previously unleveled data based on the structure of the graph and the similarity between the data points. Next question. This is again one important question. State the formal definition of Markov decision process, MDP, and define the Markov property. Markov decision process एक very common नाम है. तो क्या है ये Markov decision process is a mathematical model we use in reinforcement learning to describe how an agent interacts with its environment. It provides all the information needed for the agent to make decision and learn based sequences of action. तो MDP एक मैथमेटिकल मॉडल है जो हम reinforcement लर्निंग में यूज करते हैं. ये डिस्क्राइब करते हैं कि कैसे इंटरेक्ट करे एनवायरनमेंट के साथ एजेंट. फॉर्मल डेफिनेशन MDP, and MDP is represented as S A P R gamma. Here S is the set of all possible state. Here is the set of all possible actions the agent can take. P, capital P, is the transition probability which gives the probability of moving from one step to another after taking an action. Transition probability. Okay. Then R is the reward function, which tells the agent how good and bad an action is. And then gamma is the discount factor, which determines how much the agent values future rewards compared to immediate rewards. So together, these 5 components completely describe the reinforcement learning problem. These are the 5 components: S, set of states; A, set of all possible action; P, transition probability; R, reward function; gamma is the discount factor, which determine how much agent values future rewards compared to internal immediate rewards. So for an example, robot learning to move inside a maze. S, robot's current position in the maze; A, moving up or down or left or right. Transition probability B is after moving right, there is a 90% chance that robot moves correctly and a 10% chance it slips. Right. Reach the goal. Reward के case में reach the goal +100, hit a wall -10, and normal movement -1. Right. Discount factor gamma, that is determines whether the robot prefers immediate rewards or is willing to wait or larger future rewards. Markov property says that this is the most important assumption in MDP, that states that the next state depends only on the current state and the current action. जो next state है current state और current action के ऊपर depend करते हैं. It does not depend on what happened earlier. पहले क्या हुआ था इससे कोई मतलब नहीं. In simple words, the present contains all the information needed to predict the future. So P st plus 1, st at, st minus 1, at minus 1, to P st plus 1, st at. St is the current state, at is the current action, st plus 1 next state, P is the probability of moving to the next state. Now this equation shows that once we know the current state and current action, the previous states and actions are no longer needed. Okay, suppose for example, a robot is currently at room B. It decides to move right. Whether a robot came from room A, C, or any other room, it doesn't matter. The next state depends on beyond the current state, that is the room B. अभी कहाँ पे है? B में current action के move right जाना है. पहले B से पहले वो A में था, C में था, इससे कोई मतलब नहीं. The robot's earlier port has no effect on predicting the next state. Why is the Markov property important? Markov property makes reinforcement learning simpler because the agent only needs to know the current state, right? Does not have to remember the complete history of the previous state and action. Learning and decision making becomes faster and more efficient. तो मार्कअप प्रॉपर्टी इंपॉर्टेंट होता है क्योंकि पहले का सीधे हमें जानने की जरूरत नहीं पड़ता है, राइट. अभी जो है किसी करंट स्टेट्स के बारे में जानना जरूरी होता है, राइट. हमारे में हम बोल सकते हैं मार्कअप डिसीजन प्रोसेस MVP is represented by MVP is equal to type components as A, P, R, gamma. S is the states, A is the actions, P is the transition probabilities, R is the reward function, and gamma is the discount factors, right? Now, the Markov property states that the next states depends only on the current states and the current action, not on the sequence of previous actions or states. Its mathematical representation is that PST plus 1, ST, AT, ST minus 1, AT minus 1 is PST plus 1, ST, and AT. So this property forms the foundation of most reinforcement learning algorithm because it always allows the agent to make decision using only the current situation rather than the entire history. तो ये जो मार्कअप प्रॉपर्टी है इसी के थ्रू पे रीइंफोर्समेंट मोस्ट ऑफ द रीइंफोर्समेंट लर्निंग एल्गोरिथम काम करता है, क्योंकि इसका मेन बेसिस ही ये है कि जो अभी का एजेंट को अभी का डिसीजन मेक करने के लिए बहुत पहले का हिस्ट्री जानने की जरूरत नहीं होता है, सिर्फ करंट सिचुएशन जानना ही काफी है. Then what happens mathematically if you said, next question is that what happens mathematically if you say RL discount factor gamma is equal to 0 versus gamma is equal to 1. The discount factor gamma is an important parameter in reinforcement learning. It determines that how much importance the agent gives to future rewards compared to the immediate rewards, right? So the value of gamma always lies between 0 and 1. Gamma is greater than equal to 0, less than equal to 1. A small gamma makes the agent focus on immediate reward, while a large gamma makes the agent considers future rewards as well. तो क्या हो रहा है यहाँ पे कि आप देखिए जो डिस्काउंट फैक्टर गामा है ये एक इम्पोर्टेंट पैरामीटर है जो कि डिटरमाइन करता है कि हाउ मच इम्पोर्टेंस द एजेंट गिव्स टू फ्यूचर रिवॉर्ड्स को कितना इम्पोर्टेंस दे रहा है एजेंट कंपेयर टू द इमीडिएट रिवॉर्ड. इमीडिएट रिवॉर्ड से कितना ज़्यादा इम्पोर्टेंस फ्यूचर रिवॉर्ड को एजेंट दे रहा है वो डिटरमाइन करते हैं डिस्काउंट फैक्टर. इसका वैल्यू होता है 0 से लेके 1 तक, राइट. स्मॉल अगर होगा गामा का वैल्यू मतलब डिस्काउंट फैक्टर का वैल्यू, तो दिस मीन्स एजेंट फोकसेस ऑन इमीडिएट रिवॉर्ड, अभी वाले, राइट। अगर ज़्यादा होगा गामा का वैल्यू तो मीन्स फ्यूचर रिवॉर्ड को ज़्यादा इंपॉर्टेंस दे रहा है। टू टेल रिवॉर्ड दैट एन एजेंट ट्राइज टू मैक्सिमाइज इज कॉल्ड रिटर्न। जितना रिवॉर्ड एजेंट मैक्सिमाइज करने की कोशिश करे इसको आप रिटर्न बोलते हैं। मैथमेटिकल इक्वेशन इज इक्वल टू जी टी इज इक्वल टू आर टी प्लस वन गामा आर टी plus 2 gamma RT plus 3 gamma cube RT plus 4 like that. ये जो GT है, GT is the total reward return starting at time T. RT plus 1 is the immediate reward. RT plus 1, RT plus 2, RT plus 3, ये सब जितने भी हैं, these are the future reward. Gamma is the discount factor. So first case when gamma is equal to zero, gamma is equal to zero होगा तो क्या होगा? If the discount factor is zero, all future rewards become zero because gamma is equal to zero. This return becomes RT plus 1, and RT plus 1 is the immediate one, right? Doesn't consider only the immediate reward and completely ignores the future rewards. This type of agent is called short-sighted, that is myopic, right? समझ में आ गया? तो गामा जीरो होने से सिर्फ एजेंट जो है सिर्फ इमीडिएट रिवॉर्ड को कंसीडर करेगा, फ्यूचर रिवॉर्ड को ये इग्नोर करेगा, और इस टाइप के एजेंट को हम बोलते हैं शॉर्ट साइटेड, राइट। सपोज ए रोबोट हैज two choices: action A immediate reward 10, future reward 0; action B immediate reward 2, future reward 100. For gamma is equal to 0, the robot will choose A, action A, because it only looks at the immediate reward. अब जब gamma is equal to 1 होगा क्या होगा? If the discount factor is 1, the future rewards are not reduced. So this becomes, returns becomes RT plus 1. It is equal to RT plus 1, RT plus 2, RT plus 4, RT plus 3, RT plus 4, like that. And then treat immediate rewards and future rewards equally. So it try to maximize the total rewards over time. तो इसमें सबको साथ में चलते हैं लेके, तो जो गामा इज इक्वल टू 1 होगा, द रोबोट एक्स चूजेस सेक्शन बी बिकॉज द टोटल रिवॉर्ड इज मास हायर, राइट, टोटल रिवॉर्ड ज़्यादा है। Why can gamma is equal to 1 be a problem? Because if the task has no ending and infinite horizon problem, the rewards continue forever, like 1 plus 1 plus. So this sum keeps increasing without limit. As a result, total reward can become infinite and making learning unstoppable or unstable. For this reason, many reinforcement learning use a value such as gamma is equal to 0.9 और गामा इज इक्वल टू 0.99, और वन नहीं लेगा, या तो जीरो लेगा या तो 0.9, ठीक है। दिस वैल्यू स्टिल एनकरेज लॉन्ग टर्म प्लानिंग व्हाइल कीपिंग द टोटल रिवॉर्ड फाइनाइट। समझ में आ गया? So gamma is equal to 0 mana considers only the immediate reward. Short-term planning, gamma is equal to 1 means considers future rewards too, right? Long-term planning. So discount factor controls the importance of future rewards. Return is calculated at gamma t is equal to gt is equal to rt plus 1, rt gamma rt plus 2, gamma square t plus t, like that. Gamma is equal to 0 means as is short-sighted, optimize only the immediate reward, and gamma t is equal to rt plus 1. When gamma is equal to 1, then as in we can gives equal importance to immediate and future rewards. Gt is equal to rt plus 1, rt plus 2, rt plus 3, like that. This works well for tasks having a definite ending, but in case of in the tasks that continue indefinitely, it can cause total value to grow without bound, making learning difficult. So हम इसलिए गामा का वैल्यू 0.99 ले लेते हैं। तो इसके साथ ही ये क्लास हम कंप्लीट करते हैं। That's it. Thank you.